Hi, I'm Pat. All right, this is an equation. We're supposed to solve the equation, right? But the directions even tell you to use a half-angle identity to solve the equation. And you know that there are a couple of these different half-angle identities. So the first task might be to decide which one's the right one to use. And of course, that'll depend on a different problem. If you're doing it, what you're looking for is the expression that's given or involved somewhere inside the equation that you're working with. Which half-angle identity does that most look like? Okay, so I wrote one down here, the tan of x over 2. And this is what I meant by most looks like, is see how there's a fraction on the right-hand side with a sign up top and a 1 plus cosine on the bottom. It's pretty much exactly what I have going on right here. Okay, so different problems might involve different expressions and different half-angle identities, but look for the one that best fits the problem you're working on, and then let's take it from there. Okay, so I'll put that aside even for now, because I will use that one, but let's first work on this equation by cleaning it up a little bit in terms of like the minus square root of 3. I can pretty easily throw that to the other side, right? And then I'll just be left with 3 sine of x over 1 plus cosine of x equals a positive square root of 3. A little bit of algebra, not bad at all. But I wanted to get you guys to see this because now it looks really close to the right-hand side of my identity over there, except for this 3. It's a factor of 3. It's a factor of 3. That's 3 times sine of x up in the numerator. So you can divide by it. So in my next step down, let's divide the 3 over to the other side of the equal sign. And in doing so, now notice the left-hand side of my equation exactly matches that half-angle identity that I knew I wanted to use. So that means this left-hand side can be replaced with tangent of x over 2. And the right-hand side is still there, square root of 3 over 3. Okay? So you're getting good mixes of your trigonometry abilities and also your algebra abilities. Okay, now, we're not done yet, though, until we actually try to solve for x. So tangent of some angle, I'm going to put it aside for a second that angle is actually x over 2. Let's just say tangent of some angle equals square root of 3 over 3. You've got to go back to your basics, your knowledge of like the unit circle. Which angle has a tangent of square root of 3 over 3? And I hope you're thinking that that's going to be pi over 6, all right? Pi over 6. Now, when I put it on hold for a second, that angle specifically in this problem says x over 2, all that means for me is that now I know x over 2 equals pi over 6. So when we say that the tan of some angle equals square root of 3 over 3, we know that that angle is pi over 6. But the angle for us is expressed as x over 2. And what I'm trying to make sure is clear to you is that we haven't solved for x yet, but that step that we just took was a little bit of solving the trigonometric part of this, where we had to ask what angle has a tangent of square root of 3 over 3. Okay? All right, now also don't forget with these trig functions that they're cyclic. They repeat. So pi over 6 is like my first solution, but there's another one, even within the whole unit circle, the first rotation of it, and it's exactly pi away. So it's actually plus pi. Hold on for a second. I'm going to fill in a couple blanks, but this is what I'm trying to get you to think, is that, you know what, quick sketch, unit circle. Pi over 6 is where we just found. But the other place in that unit circle that also has a tangent of square root of 3 over 3 is here, 7 pi over 6. Okay? But you can express that by saying pi over 6 plus pi. And the blank that I left was that you could keep spinning the wheel. Spin half wheels, though, because you can start at pi over 6, then you can go pi, which is just half of a rotation, and then you could do another half and go back and back and back and back. So it's n pi, okay? And we could also, of course, go in the clockwise direction. So I'm going to say plus or minus n pi. That's a bit of trigonometric thinking, but we're still not done with our algebra either, because we haven't solved for x quite yet. But the algebra is not too involved at this point, because all I'm going to do is multiply by 2 to get x alone. So x equals, and when I multiply by 2, I don't care that my expression on the right-hand side has become kind of involved with pluses and minuses and n's and whatnot. It doesn't matter. Go ahead and multiply by 2. So the first term becomes just pi over 3. And the second term keeps the plus or minus, keeps the n, keeps the pi. We're just multiplying by 2. 2n pi is going to give us that spin around the circle by halves in order to get the other angles that work. Okay? That's my answer for this equation. Hope that helped you. Make sure you practice more on your own too, though.